Hey everyone, welcome back to the Majesty of Reason. I'm Joe Schmid, and today we're joined by Dr. Daniel Linford and Phil Halper to respond to a recent video from Dr. William Lane Craig on the Kalam cosmological argument. Dr. Daniel Linford is an instructor at Old Dominion University. His research focuses primarily on the philosophy of physics and philosophy of religion. His dissertation, entitled Cosmic Skepticism and the Beginning of Physical Reality, which I've linked in the description, you can all freely read it. The dissertation is extremely relevant to today's discussion because therein, Dan gives a comprehensive and, in my view, quite convincing case that science alone should leave us agnostic about whether all of physical reality had a beginning. And he also, of course, covers and responds to some of the philosophical arguments for the beginning of the universe as well. Turning now to Phil. Phil Halper is a YouTuber who has interviewed loads of the world's leading cosmologists on his YouTube channel, which I've also linked in the description. He's a fellow at the Royal Astronomical Society, and in addition to a number of published articles, he has a book coming out. So, Phil, could you say a little bit about that book before we dig into the William Lane Craig video?
Yeah, sure. So it's kind of very loosely based on my video series called Before the Big Bang, where, as you say, we interviewed Stephen Hawking, Roger Penrose, loads and loads of leading cosmologists, and then one of them is Niayesh Afshordi, who has worked on several cosmological models of the early universe, which is quite rare. Not many people do that. And we started chatting and we said, well, let's do a book of this. The book's quite different to the video series. There we just tried to explain the science, but it's more, we hope to have a bit more drama and more storytelling and also models that we didn't cover in the video series. So I'm really excited. It's called Battle of the Big Bang, New Tales of Our Cosmic Origins. It's published by the University of Chicago Press, and it's already available for pre-order on their website, but I have to say I haven't been pushing that yet because we haven't got a cover. It's not coming out till next spring. So I actually going to push it officially like when the cover comes out, maybe. But yeah, that's the book. We're really excited about it. I can't wait for you to read it.
Awesome. And I will be putting a link to pre-ordering it in the description. All right. So as I said earlier, we're going to be responding to this recent video that Dr. Craig put out. It's called Fixing the Kalam Cosmological Argument from a couple days ago. And yeah, let's just dig in, and we'll just periodically pause it and respond.
Bill, occasionally I look around to see if there are any recent responses to the Kalam cosmological argument. I found two on YouTube, so I have some video clips for you to check out. You may be a little disappointed, Bill. I don't think there's anything that new in these, but we'll look at them. The first set of clips is from science communicator Grayson Hawk. This video has over 2,500 views. He claims he can fix the Kalam so that it's more accurate. So let's check out his first clip.
Being a science communicator on YouTube who talks to a lot of theist apologists, I very often hear the Kalam cosmological argument for the existence of God. Except that it's not exactly an argument for the existence of God. Popularized by William Lane Craig, very, very famous Christian apologist. Covered him on the channel before. 1, all things that begin to exist have a cause. 2, the universe began to exist. 3, a conclusion, therefore the universe had a cause, which the observant viewer may notice is actually not an argument for the existence of God. Now, there's a lot of, introduction of some more assumptions, a lot of mental gymnastics to go from the universe had a cause to that cause was a personal, all-knowing, all-loving, all-good God. But yeah, that's what the Christian apologists are trying to do. The primary Kalam argument just concludes with that conclusion that the universe did have a cause.
Well, so he calls the conceptual analysis of the cause mental gymnastics, Bill.
Yes, what he does is he presents half of the argument and then says it doesn't justify the final conclusion. Well, that is, of course, because it's incomplete as he presents it. If anything, he should accuse me of oversimplifying a much more complex argument, which involves a derivation of the properties of the first cause that show that this cause must be a first, uncaused, beginningless, timeless, changeless, spaceless, immaterial, enormously powerful, personal creator of the universe, which I think is a legitimate and sufficiently robust concept to qualify as a concept of God.
Later on in this video, Craig complains that people should really be responding to, they should understand when an objection has been raised before, and they should be conversant with the literature on that response. Now, in this particular instance, Craig is rightly so on the one hand, here's what Craig is doing right. He's right that the Kalam argument is not just those two premises and that conclusion. Though, to be fair, I often refer to that as the Kalam argument. there's a second stage to the Kalam argument that Craig and others often include, and that's this argument that not only must there be a cause of the universe, but the cause of the universe must have various attributes, and that those attributes are the attributes of God, and therefore we should think that God created the universe. Now, in terms of responding to objections that are already out there in the literature, well, you have a previous video, but as do other people have previous year sources showing why we don't find the second stage of the argument convincing. And it seems like, it seems like Craig himself is being dismissive here with the complaint that's being raised. I mean, the complaint, I think, should be something like, look, the strongest case that there is for this argument is for the first stage. But the second stage of the argument is usually seen as being extremely weak. And insofar as the second stage is weak, then the argument doesn't really establish, even if the first stage is successful, the argument does not successfully establish that God exists.
So I would also point out that we made a video on the Kalam cosmological argument, and we had a lot of the world's leading scholars, philosophers, physicists, a lot of the physicists that Craig quotes. Now, Craig did a 4-part reply, and then we did a reply again. This video is again got a lot of leading scholars in it, and he hasn't replied to that. So I do question why he's replying to this video and claiming, oh, nothing new here. That video got 2,500 views. Our reply video, I can't remember, 70-something thousand views. But even if it had 1,000 views, the fact is we got a lot of leading scholars to reply to him, and he hasn't replied back. So, so I don't think they can complain about, oh, nothing new here.
I think the one thing that could be said here, to be fair to Craig, is that I don't think that he picks out these videos himself. I think this may be a video that the other gentleman in this video picked out. At least that's the way they're portraying it, right? Like this other guy found this and showing it to Craig.
I think, Dan, that he clearly must have seen, if he did 4 videos replying to our video, and he's also made other videos replying to our video. I think he's done at least 7 videos replying to stuff on my channel. It's hard to believe he didn't watch a reply video. I find that hard to believe. Also, of course, we made the video with you we have this show called The Sci-Fi Show. It's me, Dan, and Alex Malpass. And we did a show on one of Dan's papers. It was called The Interface Dilemma. And that is a new argument. I don't think you see that argument in a lot of atheists or counter-apologetics. Now, you might say, well, maybe he didn't see that video. Okay, maybe he didn't, but it's published in the literature.
Well, but I think he has seen that, from what I understand, and I may be wrong about this, but from what I understand, Craig plans to respond to that paper in his forthcoming book on systematic theology. So
that's fair. Okay,
we will be seeing. So I think we will be seeing a response from him in the future to that.
Okay, that's fair enough.
Yes, and you can stay tuned. You guys can stay tuned to the Majesty of Reason for a response to that as well. So it'll be, we're going to prove the existence of actual infinities by making infinitely many responses and counter-responses. That's what's going to happen. Okay, so we're
going to do uncountably infinite responses.
Right? No, exactly. So I just wanted to plug, the earlier video that Dan and I made responding to. So Craig makes these animated videos, kind of animating these various arguments that he's defended for God's existence, and I did one with Alex Malpass on the kind of Hilbert's Hotel and philosophical case. And I also did one with Dan on the kind of scientific case and also stage 2. We talked about the various inferences that Craig just mentioned to allegedly divine attributes. And Dan and I basically raised criticisms and various problems for almost every single inference that Craig tries to make. So audience, check that out if you're interested. But how about we get back to the Kalam cosmological argument video.
Here's the next clip where he attempts to fix the first premise. Let's go to that.
Is that a good argument? No, it's not a good argument. I have really big issues with both premises. I think that both premises are not true, or at least not justifiably true. So I thought, you know what? Let's try to take a crack at fixing the Kalam cosmological argument. Let's go into each one of these flawed premises and fix them to make them true. And let's see if that alters the conclusion at all, shall we? Let's find out. So premise number 1, all things that begin to exist have a cause. Sometimes alternatively worded that whatever begins to exist has a cause for its existence. What are some examples of things that have begun to exist, right? Like we could just throw out a random example, like a chair, like the chair I'm sitting on right now. That's a thing. A chair is a thing. This chair is a thing. And it began to exist, right? Somebody put together this chair or was assembled at a factory. The wood is made primarily of carbon atoms, and those carbon atoms already existed in the air, in the carbon dioxide in the air. That's where the tree got the material to make the wood, and so on and so on and so on. You can continue to trace this chain all the way back, and you will not find a verifiable instance where you can say, yes, this is when this thing began to exist. The creation of the chair was not some ex nihilo creation out of nothing. It was just a rearrangement of previously existing parts. In fact, I would say that there are zero examples of that, zero verifiable examples of anything coming into existence from nothing.
I also noticed in the comments of this video, Bill, that people are saying that matter is neither created nor destroyed, just transformed. The first law of thermodynamics.
This response involves a fundamental confusion of efficient causality and material causality. An efficient cause is that which brings the effect into being. So take the chair. The chair is brought into being by a carpenter, and so the carpenter is the efficient cause of the chair, which begins to exist. The chair also has a material cause, namely the wood and the carbon atoms of which it's made. And the fact that the chair has a material cause in no way suggests that the chair itself doesn't begin to exist. The chair is not past eternal, even if the carbon make it up pre-exists the chair.
Yeah, so Craig seems to think that Grayson's objection here is that the nothing begins to exist because everything has a material cause. Everything is made from pre-existing, or everything we have ordinary experience with is made from pre-existing materials. And so Craig thinks that Grayson is arguing that this means that nothing actually or really begins to exist. But that's not what Grayson is arguing. And if you watch Grayson's video, that's not what Grayson ends up saying. So, Grayson is quoted here as saying a few things that make it sound as though that's what he's saying. But really, what Grayson is saying is that what it means for something to begin to exist is that it is produced from pre-existing materials. Now, if Craig were right that if Craig were right that Grayson were arguing that nothing begins to exist, then in fact what Craig should have said is that Grayson is not presenting an argument against the causal principle. Because the causal principle, so if nothing began to exist, then the causal principle that anything that begins to exist has a cause would just be trivially true. Right? So if nothing at all begins to exist, well, then it's true that of all of the things that do begin to exist, that they have a cause. It's vacuously true or trivially true. But what I think Grayson really is arguing is that either we understand the causal principle as a principle about things begin to exist in this, what Grayson takes to be an ordinary sense, which is that everything we've experienced with is produced from some pre-existing stuff, or we interpret the causal principle as having to do with creation ex nihilo, in which case the causal principle is just unjustified because we have no experience with things that begin to exist ex nihilo. So so Grayson thinks that the causal principle is either irrelevant to the conclusion or unjustified. That's the way that I think we should be understanding what Grayson is saying. Now, I don't think that we really should understand the causal principle in that way. I think that we should understand the causal principle to be the principle that everything that begins to exist has an efficient cause. And if that's the way that you understand the causal principle, we're here, by the way, begin to exist, it's just taken in the broadest sense possible. Whether it begins to exist from pre-existing materials or from nothing at all, the causal principle claims that things have efficient causes. Now, I think there's another kind of reason that you might object to that principle, which is close to what Grayson is saying. You might point out that that interpretation, that the causal principle under that interpretation is no more well justified than another principle that I'll call the material causal principle, according to which everything that begins to exist has a material cause. And if that principle is just as well justified as Craig's causal principle, well, then they stand or fall together. Right? If it's really true that Craig's causal principle is no more justified than the material causal principle, then if we should reject the material causal principle, we should likewise reject the causal principle. Or if we should accept the one of those, we should accept the other. But if we do accept both, then then we should reject the conclusion of the Kalam argument, because the conclusion would require that there be no material cause or no pre-existing material from which the physical universe is made.
Yeah, and you could also even slightly weaken, so we could consider a weakened material causal principle, which just says that whenever something begins to exist, we could even restrict it to whenever material things begin to exist. And moreover, we could restrict the principle in a further way to say whenever material things begin to exist, they have a material cause if they have an efficient cause at all. And that's an even further weakened principle, which is just as arguably well supported by our inductive universal experience as the original causal principle. To many people, it seems just as intuitively plausible as the causal principle. I mean, just as we wouldn't take seriously someone suggesting that, a log cabin in the woods just sprang into being uncaused without an efficient cause. Likewise, we wouldn't take seriously someone saying that they kind of just conjured into being via their efficient causal power a log cabin without making the log cabin from any pre-existing materials. We would take that to be absurd as well. So I
think it's relevant to say what Craig's alternative is that God spoke the universe into existence. And if we can reject, that it didn't have a cause because of our everyday experience, I can reject that someone can speak something into existence from the very same reason.
I mean, this gets close to like one of the things I find just really sort of bizarre about the way that Craig tends to argue. So on the one hand, we're told that various non-theistic cosmological models are supposed to be bad, quote unquote, because they're overly speculative or they don't have sharply enough defined mechanisms and so on. Now, on the one hand, there is a sense in which many of those models are sharply defined. But on the other hand, I can't think of something that's less well defined than the sense in which God is supposed to have created the universe. I mean, we have, not only is it that we have no prior experience with something being an efficient cause without there being a material cause, but we have Craig's theology itself doesn't provide us any sort of mechanism by which this is supposed to happen. It's entirely underdefined in terms of how this is supposed to happen. You bring up this idea that it was supposed to have been spoken into existence. But of course, that's taken in a metaphorical sense.
Right.
And then one wonders, what is this supposed to be a metaphor for? And of course, there's just no answer.
What we're interested in is what are the causal conditions for something that begins to exist? The fact that the things begin to exist all the time is evident, for example, from the fact that we ourselves begin to exist. I'd invite Grayson to ask himself, did he begin to exist? Does he think that he existed prior to the union of his mother's egg and his father's sperm? Does he think that he is past eternal, that he has always existed? Well, of course not. He began to exist at that moment of conception. And so the fact that things have material causes in addition to efficient causes is in no sense a refutation of the evident fact that things do begin to exist all around us all the time.
Grayson, again, is not arguing that nothing begins to exist. Grayson would never say that he didn't begin to exist. Instead, what Grayson would say is that he began to exist in the sense that he was created from pre-existing materials. And so this entire line of argumentation that Craig has embarked upon is just a reply to a straw man.
Yeah, right. And so I haven't watched the Grayson video in full, but I did watch a relevant portion, Dan, that you sent me, where Grayson, he explicitly says that when I think this is almost a quote from Grayson. He said it's around the 4-minute, 30-second mark. He says, when we say that something begins to exist, we mean that it was produced by pre-existent materials. And of course, Grayson is arguing that his chair was in fact produced by pre-existing materials.
Right.
So he is saying that things
point.
he is saying that things begin to exist. We have him committing himself to saying that things do in fact begin to exist. So I just want to say that for the audience. But let's continue on with Craig.
Begin to exist all around us all the time.
And here's the next clip. He goes on to premise number 2, gets into the Big Bang.
Now, what about premise 2, right? Premise 2 was that the universe began to exist. Now, on its face of it, a lot of people might have learned about the Big Bang as being the beginning of the universe. But does the Big Bang actually make any such claim? When you get right down to it, most theoretical physicists, astrophysicists, and cosmologists agree that it does not. The Big Bang does not make any claims about where the starting energy of the universe came from. It starts at the initial condition of the universe existing in a very, very small, very, very dense, very, very hot state. In fact, the actual physics that we need to describe this state break down, and we're no longer able to describe the very, very smallest, hottest, densest states about what is actually physically going on. So without that more advanced physics necessary to describe what's going on, you really cannot make any assertive claim about any kind of beginnings. It's only intellectually honest to be agnostic about whether or not our evidence or theories today point to a beginning of the universe. And again, most cosmologists would agree with this.
So is agnosticism about the Big Bang the best option, Bill?
Well, I think that Grayson is simply wrong, that most cosmologists agree that the universe did not begin to exist. I wonder what is his basis for saying that? Why should we believe him in this regard? I noticed that Stephen Hawking and Roger Penrose, two of the greatest physicists of all time, in their co-authored book, The Nature of Space and Time, published by Princeton University Press, have the following to say, and I quote, "Almost everyone now believes that the universe and time itself had a beginning at the Big Bang."
Okay, so this quote is extremely dodgy for a number of reasons. Firstly, so it's true that quote is in that book, and that book is is authored by Hawking and Penrose. What Craig doesn't tell you is that it was a debate between Hawking and Penrose, right? So that quote comes from Hawking, don't come from Penrose. So it's sort of dodgy for him to attribute it to Hawking and Penrose. But moreover, of course, now at the time, to be fair to Craig, at the time probably Penrose did agree with Hawking, but we all know, surely Craig knows, that Penrose changed his mind, right? And Penrose now thinks that the universe doesn't have a beginning. And it's not
just as a point of clarification, so at the time when that book was published in 1996, Hawking did not think that the universe had a beginning, right? So the claim that Hawking has made here is just a claim about what it is that a community of people believe, and not a claim about what either Hawking or Penrose themselves believe.
No, but he is attributing it to Hawking and Penrose, and he said, these are two of the greatest physicists of all time. So he is using their authority, right? I don't know if they're of all time. I mean, they're certainly very highly respected physicists. Penrose has got a Nobel Prize. Hawking, of course, is a great physicist. Yeah. But anyway, he's using their authority, right? And if we can use their authority to establish a beginning, then I can use Penrose's authority to establish the opposite, because he doesn't now think that the universe is right? So I could just flip his argument against him. But most importantly, what I think is really important is the date of that. Now, I think the debate happened in 1994, and it got published a bit later, a year or two later. But the important thing is that if you read the book, Hawking basically says, well, we've got these singularity theorems. They prove the universe has a beginning, but he concedes that, we need a quantum cosmology. And he says, I don't think string theory is going to change the conclusion of the beginning. But no one had constructed a model of cosmology using string theory at that time. But a few years later, they had started to do so. And not just, I don't know why Hawking only mentioned string theory, because there were other competitive quantum gravity theories like loop quantum gravity or causal sets. But certainly people have constructed models of the Big Bang using these ideas. Now, I'm not trying to say these are right. These are just sort of ideas people are kicking around. But they imply actually the universe, many of them imply that the universe doesn't have a beginning. It certainly didn't begin at the Big Bang. So this quote is not only sort of incorrectly attributed to Hawking and Penrose when it was really just Hawking, but the date is really, really relevant because things changed in the late 90s and the early 2000s. In particular, we found that one of the conditions of the theorem, the Penrose-Hawking theorem that's supposed to prove the universe had a beginning, was actually violated. Observationally, we have evidence that it's violated. That condition is basically that, well, it's an energy condition, but you can put it in English, plain English, as just saying gravity is always attractive. So when we found the universe is accelerating expansion, we had evidence that that's not true. People had proposed inflation before that would also violate that condition. So in the late 90s, we really had very strong evidence that one of the conditions of the theorem wasn't true. But also then they start in the late 90s, also in early 2000s, people started to develop cosmological models based on quantum gravity ideas, and they seem to imply the Big Bang wasn't the beginning. Moreover, in the 80s, the only quantum cosmology models that we had, so before 1994, when that quote was made, were models like the Hartle-Hawking model and the Vilenkin tunneling from nothing model, which can be interpreted as having a beginning, or at least the past is finite. But then we got these other models that sort of had a different conclusion, and so again, the date is really important here. The last point I'll make about this quote is that Craig can't really help himself to Hawking here, because what happened was Hawking sort of had these singularity theorems, and then he agreed that we need a quantum update because general relativity is probably inapplicable in this high density regime. So Hawking constructed a model called the Hartle-Hawking model with Jim Hartle, and Hawking interpreted that model as having a beginning. Okay, but the model has sort of two types of time in it, like real time, the sort of time that you're familiar with, but imaginary time as well. So imaginary time is, you might have heard of the fact that there are, if you take the square root of 9, right, the square root of 9 is 3, and it's also -3, right? There are no numbers that that everyday people will be familiar with that square to a negative number. If you take -3 times -3, you get +9. +3 times +3 is +9, right? You don't get -9. So imaginary numbers are numbers that mathematicians have sort of developed that do give you a negative number. So when you square them, so these are imaginary numbers. Now, the beginning in the Hartle-Hawking model is in imaginary time. If you follow it in real time, it doesn't have a beginning, right? Now, Craig thinks that imaginary time is physically unintelligible. That's his main critique of the Hartle-Hawking model. So he can't help himself to Hawking's quote, right, as saying, I think the universe had a beginning, right? Because he can't consistently do that. Just to say, it's not just me sort of saying this. There's a quote here from Aaron Wall. Aaron Wall is a Christian theoretical physicist, and this is what he said about this. He goes, the supposed beginning of time, this is a quote now, sorry, open quote, the supposed beginning of time actually occurs at values of the time parameter that are imaginary. If you only think about values of t which are real, most calculations seem to indicate with high probability you get a universe which is eternal in both directions. Now, later on, he sort of accused people of saying that the Hartle-Hawking model had a beginning were lying, or I think he said, well, they're not really lying, but the end result is the same. I'm sure their motives are as clear as they've driven so. But he was very, critical of people saying the Hartle-Hawking model has a beginning. So, but of course, this is what's implied. It didn't say it explicitly, Craig, but by quoting Hawking, I think this is implied. So those three sort of major problems with this quote. Now, if you want, I can play you lots of cosmologists saying we don't believe, that singularity is real, that we don't, that it basically completely confirms what Grayson says. So it's up to you, Joe, whether you want to play these clips or here's a few things. So let's start with Penrose.
Certainly a view quite commonly expressed now that we shouldn't simply give up that the Big Bang is a singularity, that we need a theory which describes that. Most people would say it's a form of quantum gravity. I have a view which is different from that, but nevertheless, I have in common with that we need a new theory.
The real lesson of the singularity theorems is therefore that we need to combine the general theory of relativity with quantum theory in order to understand the origin of the universe.
What is called the standard Big Bang cosmology, which was a hot Big Bang, right? You start with a very hot, dense universe, and which begins at singularity. So that picture, I don't think anybody believes.
I don't think anybody believes that the universe started off with the singularity. That just tells us that Einstein's classical theory of general relativity breaks down. So that classical theory of gravity doesn't apply when you get to very high energies. So it's replaced by some quantum theory, consistent quantum theory of gravity. String theory is a candidate for a theory like this.
Was there a Big Bang?
Okay, I'll stop it there.
Well,
The main comment to make is everyone agrees that it's the singularity theorem that gives you the justification for the beginning of the universe, and the singularity theorem can't be trusted. Now, Hawking was saying, well, I still think there's a beginning, but you have to unpack why does he think that? And I've been in his office and I've interviewed him and I've spoken to his colleagues, and I think the reason is that he interprets the Hartle-Hawking model as still having a beginning, and so he thinks there's still a beginning in quantum cosmology. But what you have to understand is that there's lots of different competing quantum cosmologies, and they don't all say the universe has a beginning. All right. And as we said, the beginning of the Hartle-Hawking model is in imaginary time anyway, which Craig cannot buy into. So, yeah, it's extremely problematic for Craig.
Yeah, and there's currently no expert consensus among cosmologists and physicists about which of those models is the correct one, right?
That's right.
Yeah.
Right. So I just think it's way too premature for Craig to kind of appeal to science. I'm sure, but
yeah, that's right. And sometimes what I think we can hear this, Craig say this later on, but sometimes Craig will admit that, yes, we don't know that the universe began in a singularity. And then he wants to go on to say that nonetheless, we somehow do know the universe began. I don't understand this on two levels. One level I don't understand it is that he uses the singularity theorems to try to support what he's saying. And on the other hand, I don't understand it because the only reason at all that anyone thinks that these various physical models give us a beginning is because they have things like singularities in them. Once you give up those results, once you say, oh, we can't trust the singularity theorems because they were produced in the context of, for example, classical spacetimes, but we know that there has to be some quantum gravity theories so that spacetime isn't actually classical. Well, then it's the same moment when you give up any justification you had for thinking that there was going to be a physical theory that told you about the beginning of the universe in the first place. So it's just sort of bizarre that that he wants to like somehow make himself a road in between these results.
Yeah, no, I think the thing is that Hawking did make that point, that he did say in our film with him, we said, well, the singularity theorem proves the universe had a beginning, but it doesn't say how it began. And he thinks the Hartle-Hawking model is how it began. So I think Hawking did make that point, but I think I agree with Dan that it doesn't really make sense, because if you abandon the singularities, then it's just open whether the universe had a beginning. Right. Now, I should say, watch on my channel, Phil Halper, I'm going to be hosting a debate with one of Hawking's colleagues and another cosmologist that doesn't think the universe had a beginning, and I'm going to put that to him, and we'll see what happens. So that actually, we are planning to record that on Thursday. But you never know. I haven't sort of announced it too much because you never know, people reschedule things. So, but that is the plan, that we're supposed to be recording that debate on Thursday. So you'll hear a scientific debate on whether the universe had a beginning. And it's weird because how could such a debate even happen if everyone agrees? So
I think
they don't.
I think this gets close to what is to me a really crucial central point, which is just the following. Craig, in many of his papers, and sometimes these are co-authored with people like James Sinclair, argues that like no particular cosmological model, that is no particular beginningless cosmological model is probable. Now, I disagree with various arguments that Craig has for establishing that conclusion, but let's suppose it's right. Let's suppose that it's right that no particular cosmological model is probable. Nothing at all follows from that about whether it's probable that the universe is beginningless. Why is that? Well, consider a lottery. So in a lottery, it's improbable that any particular ticket will win. Nonetheless, it's probable that some ticket or other will win. And so likewise, even if it's true that none of the beginningless cosmological models that have been offered so far are probable, it doesn't follow that probably the universe is beginningless. The sort of connecting point here is that, so sometimes people will want to say, oh, I think that there are various probable beginningless cosmological models. I sometimes hear like naturalists or physicalists or atheists on the internet say things like that. Well, they have to be mistaken. Why is that? Because you can't have more than one cosmological model that is probable. Or at least if the models are mutually exclusive, there can't be more than one that's probable. Well, if we want to say that they're all live and they're all in live competition with one another, that there's some meaningful debate to be had between them, that we want to choose carefully among, then what we should say is that none of them are probable. So we don't need to go through Craig's entire argument to show that that no individual beginningless cosmological model is probable. We already knew that. And anyone who has their ear on the ground in physics and understands what it is that physicists are interested in and what they're currently working on knows that there is no beginningless cosmological model that is probable. And likewise, there's no cosmological model with a beginning that's probable. No cosmological model is probable. And so it shouldn't be that the whole discussion shouldn't be about whether or not we have any specific cosmological model that's probable. We already know that there isn't one.
Challenge for Craig. Tell us which cosmological model you think is probable.
Right.
Of the very early universe, right?
Yeah,
Not
right.
About, expansion from a hot dense state, but, something that happened, maybe before inflation, if inflation happened.
Yeah, something beyond just traditional Big Bang cosmology, something that doesn't look like it was just written down in the 1950s. And if you can do that, then that would be interesting and impressive, but it also involve him putting his neck out on the line. I think the only last point I want to make here is that we have purely philosophical reasons for thinking that the BGV theorem has no importance for whether the universe has a beginning. And that's that. So Craig thinks that God entered time, a finite time, into the past. Craig also thinks that God is beginningless. Therefore, Craig thinks that there are things that have a finite past, that have only existed for finite time, and yet are beginningless. The BGV theorem at most tells us that the universe has been around for a finite time. But given Craig's own theological view, it's just false that if something has been around for a finite time, that alone would suffice for showing that it had a beginning. So Craig needs to take an extra step. He needs to show us with a convincing argument what the extra condition is to add to having a finite past that suffices for having a beginning. And then he needs to show that the universe satisfies that condition, whatever that condition is. We don't get to go into it here. He has some proposals in the literature. I have various reasons for thinking that those proposals don't work, as you can read in my paper on the modal condition. Yeah, that's what's required, right? And so he has to say more than he said here anyway. He has to say more than just that, oh, by the way, there's this theorem which, if it applies to the universe, would show that the universe is a finite past. He needs to show that the universe satisfies whatever other condition there needs to be to have a beginning.
Yeah. So I think perhaps later in the video we're going to touch on the BGV theorem a little bit more detail. So that's a kind of foreshadowing for the audience. The second thing that I wanted to add here is that, Dan, you already kind of covered it, but it's very frustrating when I see some defenders of the Kalam say that, each model featuring a beginningless past has various problems afflicting it, as if this isn't also true of all the models featuring a beginning. This is precisely why there's still active live debate, massive disagreement among professional cosmologists and physicists and whatnot concerning which model of the cosmological history of the universe is correct. So I just think apologists and people interested in the Kalam need to stop pretending that there's like some sort of consensus that like the standard Big Bang model of the universe is like just like the correct and final word, and our universe began 13.8 billion years ago. There's far more disagreement than such people let on.
And that's what our book is about. Like, it's called The Battle of the Big Bang because it's about people with different ideas about what happened 13.8 billion years ago. They do not agree, and it can be quite feisty.
Right, and I mean, for the audience, it's not like we're like young Earth creationists or anything like that. I mean, everyone agrees that 13.8 billion years ago, our observable space-time manifold was in a very hot, dense state and rapidly expanded from that hot, dense state. No one doubts that. No one doubts that. That definitely happened.
Yeah.
What the question is the real question is, does that expansion, that start of the expansion of our observable physical spatiotemporal manifold, does that mark the absolute beginning of existence of the entire totality of all physical reality? Not just our observable universe, but all of physical reality whatsoever. And there is no expert consensus on that question. So I just want to point that out to the audience. And one point that Dan brought up, and this is, I think, a really salient point for all these arguments. I think it's a problem that afflicts the Kalam, and I don't think Kalam proponents have sufficiently attended to it, is this illicit slide from the finitude of the past to the universe began to exist. So as Dan was rightly pointing out, Craig himself recognizes that we cannot infer that something begins to exist merely from the fact that its past is finite, right? As Dan pointed out, Craig thinks God's past is finite, and yet God didn't begin to exist. Like, Craig thinks God's past is finite because, as Dan said, God exists in time since the moment of creation, and there's only ever been, in Craig's view, a finite amount of past time during which God has existed. So God has a finite past, but according to Craig, God did not begin to exist, because then otherwise he would need a cause. So what this tells us is that having a finite past is not sufficient for beginning to exist. In the case of Craig's view of God, right, God doesn't begin to exist despite having a finite past, because God existed timelessly sans creation, or timelessly without and causally prior to the creation of metric time. So then, one way for something to have a finite past and yet fail to begin to exist is if it exists timelessly sans its temporal life. But then if Craig wants to infer that the totality of all physical reality began to exist, he needs to rule out that there's some physical reality that exists timelessly sans the start of metric time, assuming that metric time actually did start. And it won't do here to merely assert that it's impossible for something physical to exist timelessly, since, one, that assertion needs to be justified, and every justification I myself at least have come across is extremely poor. And more importantly, there are perfectly coherent, empirically live models for how there could be timeless physical things. For instance, there's been a good deal of work by philosophers of physics like Alyssa Ney, Jill North, Julian Barber, David Albert, Barry Lower, on the view that there's a non-spatiotemporal universal wave function. For those interested, Dan and I actually talk about this view extensively in chapter 8 of our book, Existential Inertia and Classical Theistic Proofs. So anyway, that's just one way. For the audience, that's just one way for something to have a finite past and yet not begin to exist. And there are other ways too. So for instance, something could pre-exist the beginning of metric time in a non-metric or amorphous time, which is basically just like a temporal state for which there is no objective fact of the matter concerning its length or duration. This view has been defended in the case of God's relation to time by philosophers like Richard Swinburne, Ryan Mullins, Alan Paget, and others. And it's also been proposed for portions of cosmological history under Roger Penrose's conformal cyclic cosmology. So, again, if something pre-exists the beginning of metric time in a non-metric time, and by the way, a non-metric time would have to be beginningless, but not infinitely long, because there's no objective fact of the matter concerning its duration. So it's not like it's an infinitely long period of time, but it's also not like it's a finitely long period of time with like a definite beginning. It's neither of those. That's precisely why it's non-metric. So if something pre-exists at the beginning of metric time in a non-metric time like this, well then, even if its past is metrically finite, it doesn't like arrive anew onto the scene of reality at its first moment of metric time. And so it doesn't truly begin to exist. And actually, Craig himself seems to agree that this view would not imply that the entity pre-existing metric time in a non-metric time begins to exist. And the reason for that is that Craig himself has said in his discussion with Ryan Mullins on my channel that he thinks that this is he thinks that this Oxford school of divine temporality that I've been mentioning, which posits this non-metric time in which God pre-exists, he thinks that this is a theologically legitimate view for someone to hold in the case of God, which he wouldn't think if he thought that it made God begin to exist. So again, this is not Craig's view, but he thinks like it's like something that one could like legitimately hold in terms of like theology. So that's another way that something can have a finite past and yet fail to exist. And so again, if Greg and defenders of the Kalam want to infer that the universe began to exist, it's not enough for them to show that the past is finite and that the universe's past is metrically finite. They would also need to show that nothing physical pre-exists the beginning of metric time in a state of non-metric time. And as far as I'm aware, no one has successfully done that. There are other ways, too, for something to have a finite past without beginning to exist. So, for instance, Dan, you mentioned your paper, a modal condition for the beginning of the universe. Something could have a timeless aspect in the sense you define therein. And that's one way that you argue that something can fail to begin to exist, even though its past is metrically finite. And I guess a fourth and final way that the totality of physical reality may fail to begin to exist, even though its past is finite, is if there's a physical reality that's just timeless simpliciter, in addition to temporal physical realities whose past is collectively finite. In such a case, physical reality as a whole, as a totality, would be finite towards the past, even though it isn't true that the entirety or totality of physical reality began to exist, since at least one thing within that totality is timeless and so cannot begin to exist. So then I've just articulated 4 different ways in principle in which the universe, understood as the totality of all physical reality, could have a finite past, even though it didn't begin to exist. And I'll put a little image on the screen kind of summarizing these 4 different ways. And so the broader takeaway for the audience, in light of all this, is that it's a mistake to think that the universe began to exist merely from the fact that the past is finite. And you can't show that the universe began to exist just by showing that the past is finite. Or we have, the true cosmological model that features the finitude of the past, or things like that. To infer that the universe began to exist, you'd also have to systematically rule out each of these different ways that the universe could have a finite past without beginning to exist. And that's a task that, as far as I'm aware, no defender of the Kalam, including Craig, has ever accomplished.
And by the way, it's crucial to point out here that it's not enough just to point out that, for example, Penrose's conformal cyclic cosmology is perhaps improbable. Right? I already agree that Penrose's conformal cyclic cosmology is improbable. What you have to show is not that that's improbable, but rather that the particular feature that's included in that model is improbable, right? And you don't get that just from showing that the model is improbable. You have to show that that we have good reason to think that the universe had no point. At no duration in the universe's history was there a non-metric interval of time.
Yeah, and I'll just add something here, because people have used some of his ideas in different models.
Right.
All right. So, for example, my co-author Nihaya Shafshordi developed a model with Beth Gordon. We made a movie about it. You can see it on our channel. And the idea here is that the whole universe is what's called a closed time-like curve. So if you went forward enough into the future, you'd be like on a loop. Now, how do you get the two to combine? He uses the conformal rescaling trick of Penrose. So it's not CCC, but it does use some of the ideas of CCC, namely using the conformal rescaling to cross over.
Yeah, I mean, it's a standard trick that you can pull off in general relativistic models. And so it's, there's no requirement here that it be Penrose's specific model. In some sense, Swinburne recognizes something related in that what Swinburne says with respect to his models, that the only reason that there's a metric for time at all is because of physical law. Now, Swinburne seems to think that given physical law, there's always this metric available. What Penrose and others are saying is that maybe the laws are such that there are specific physical conditions which are such that even though you have the laws, you no longer have the metric. And there's a certain kind of consilience with what it is that Swinburne is saying, even though it's not exactly the same thing. It's similar in flavor.
Yeah, and one thing that I do want to add is whenever I bring these various points up about the illicit inference from past metrical finitude to begins to exist. Whenever I bring this up, I always get these confused commenters saying, "Oh, but those are so speculative. It's so speculative that there's like a physical reality that exists timelessly sans the beginning of metric time, and that exists temporally sans. Or it's so speculative that there'd be a non-metric time prior to the beginning of metric time. Or it's so speculative that there's some kind of non-spatio-temporal physical reality." Now, this misses the mark in several respects. There's a reason why I say that this is a confused comment. Firstly, the burden of justification in this context is on the Kalam, the proponent of the Kalam, right? They're the ones who are trying to convince us that the universe began to exist. They are the ones who need to roll up their sleeve and rule out these alternatives if they want us to infer that the universe began to exist from the finitude of the past. So the burden of justification is not on us to show that these various alternatives are in fact true. We don't need to prove these things. The point is that the proponent of the Kalam is the one who needs to convince us that these are all false. Okay, and not just that each of them individually is improbable, because we have to also consider the disjunction and the stuff about the lottery that you mentioned. Yeah. They are the ones who need to show that all of them, even collectively, are very likely false if they want us to infer that their preferred view is correct. So the point about being speculative just completely misses the mark. The onus of justification is not on us to show that this is true or to give reasons to think that it's the case. The burden is on the proponent of the Kalam to rule these out. That's the first thing to say. The second thing to say is that actually some of these do in fact have positive reasons to accept them. Again, check out chapter 8 of our book. We cite various authors, probably at least a dozen different papers or books that go into justifying at least some of these sorts of models. So there actually are reasons that have been offered for at least some of these kinds of alternatives. So that's the second way in which this confused objection misses the mark.
One last thing.
Yeah.
It's also confused because Craig's theological model is itself speculative, right? I don't understand this objection that it's okay for theological models to be speculative, but not for naturalistic ones. I don't understand this. Craig wants to say that God somehow, I don't know what the right words would be, transferred from a timeless state into a temporal state, and then, what words you use, whatever verb you use seems to be wrong. But insert whatever verb you want. There has to be some way in which they have the right explanatory order between them, and then it has to be that somehow whatever God was doing was, as we said previously, analogous to, or can be an apt metaphor for, that God spoke physical reality into being. This is entirely speculative, and it's not only is it speculative, but it lacks the kind of specificity with which physical models are usually produced. So call all these physical models speculative if you want, but they all have this feature that they are written down mathematically, whereas that nothing in Craig's model, nothing in Craig's theological model has been written down mathematically. Nothing that hasn't been expressed that way. So it entirely lacks the kind of specificity with which we would want from a non-speculative model.
What is especially significant about that quotation is the claim that time itself began at the Big Bang. That means that it is impossible that anything existed prior to the Big Bang. The universe cannot be past eternal. You cannot extend time past the initial state of the universe to infinity past. Now, Grayson would justify his agnosticism by saying that contemporary physics are not yet able to describe that initial state of the universe. In order to do that, we would need to have a marriage of general relativity theory and quantum mechanics, and we don't have that yet. We do not have a quantum theory of gravity that would enable us to describe that initial state.
This seems a little sloppy in the language, and maybe it's okay if he's talking, to a lay audience, and maybe it's okay. But I'll just point out we do have candidate theories for quantum gravity. Okay, now we don't have an agreed upon theory that we know is right. Okay, but it's not like there's a million different quantum gravity ideas out there. There's probably, I don't know, a bit more than half a dozen, something like that. You've got string theory, loop quantum gravity, causal sets, Java lift shift gravity. It's not that many, right? They do exist, right? We don't know if they're right, but the language is a little sloppy there.
We've already covered this quote, but the thing that's what's weird about this quote to me again is just that where the hell does the justification come from? Is for saying that the universe had a beginning? It's one thing if Craig wants to say, oh, there's no incompatibility between the science that we know and, say, the a priori case for a beginning of the universe. Fine. And then we can just have a debate about whether or not the a priori philosophical case has merit. But that's not what Craig does, right? Craig wants to say that the scientific case has its own merit. And once you say, oh, we can trace the universe back to a certain place, but we can't trace it back further than that. We have no idea what came before that, how do you know that that was the beginning? On what grounds do you possibly have that kind of justification? In one of his articles that he co-authored with James Sinclair, what Craig says is that, we want our physical theories to match up not future physical theories to match up with our known physical theories within particular domains. So whatever quantum gravity theory replaces general relativity, we'll have to agree with general relativity in the domains where we know what general relativity, or we've done tests of general relativity. The problem, of course, is that we have done no tests of general relativity at high energy, or at the kinds of densities we find near the Big Bang. In fact, if you take general relativity literally, if you take these general relativistic models of the beginning of the universe literally, then you could never do an experiment. Why couldn't you ever do an experiment? Because no matter how high of an energy you're able to reach in your experiment, there'll be some place further back in time, closer to that singularity, where the energy is still higher. So if you take the kind of general relativistic models literally that Craig seems to like, then what you have to say is there could never be an experiment that would give us the kind of physical knowledge that we would need in order to say that the universe had a beginning.
In order to do that, we would need to have a marriage of general relativity theory and quantum mechanics, and we don't have that yet. We do not have a quantum theory of gravity that would enable us to describe that initial state. But in order to be confident that the universe began to exist, you don't need to be able to describe that initial state of the universe. The great cosmologist Charles Misner once illustrated it in the following way in a conversation with me. He said, it's as though a tiny window shade were drawn across the first split second of the universe, and we don't know what's going on behind that shade, but we do know that it doesn't come out on the other side. I think that's an apt way of putting it. You don't need to have a physical description of the initial state to know that that initial state was indeed the beginning of the universe.
Next, Greg.
So it would be very interesting to know when that quote was, because I do think there was a belief up until the late 90s that the conclusion of a beginning that you got from the singularity theorems was not going to be changed when you got to quantum gravity. And people had created these quantum cosmology models, but they weren't really quantum cosmology models because they were what's called semi-classical. They weren't coming from a quantum theory of gravity. They were taking ideas from quantum mechanics, ideas from general relativity, and trying to marry them together. So you had the Hartle-Hawking model and the Vilenkin tunneling from nothing model, and they both can be interpreted as having a beginning. But what happened in the late 90s was then you've got models like string gas cosmology, or you've got the pre-Big Bang model, or you've got loop quantum cosmology. And all these scientists seem to be saying, actually, the universe existed before the Big Bang, and it could be eternal into the past. So that happened in the late 90s. Now, Charles Misner, when did he say this? We don't know, right? He didn't give us a reference. He just told us that that's what he said to him. We've got no way to check this. Now, at the end of the video, he's very critical of internet atheists for saying, you've got to document everything. When you kill people, you've got to document everything. He doesn't document this. He's just telling us that's what Charles Misner told him, right? So we don't know when it was said. And that when it was said is very important, because it was in the late 90s that things started to change in cosmology. The people had developed string theory, they developed loop quantum gravity, and other ideas. Finally, at the end of the 90s, beginning of the early 2000s, they started to create models of the Big Bang using them. Right, so and that's changed.
So there's various aspects of this history that I would very much like to understand better than I currently do. But one thing that I do know is that there were non-singular cosmological models already in the 1980s. So people knew, for instance, there were ways of modifying general relativity that would get rid of the singularity. So, for instance, there was Starobinsky gravity. Where you alter the trying to figure out how to say this in a way that's accessible to people, but basically there's some equations in general relativity, and when you introduce those, when you modify those equations in a certain kind of way, then you get rid of the singularities. And what justifies modifying those equations in that way? Well, you might have this idea that general relativity is going to be replaced by a quantum theory of gravity. And so you might just think, well, there's going to be we know that general relativity isn't precisely right. So there's going to be like small modifications that are not detectable in our current experiments, but that may appear when you, for instance, go to higher energies or higher space-time curvatures or whatever. Sierpinski had a particular way of modifying general relativity, and that particular way gave an early model of inflation that was an alternative to Guth's model of inflation. It also turns out that Sierpinski gravity gets rid of it gets rid of some certain kinds of singularities, like the ones that are traditionally associated with the Big Bang. There were those ideas already out there, and I don't know. I think you're right that in the 70s through maybe the 90s, there was this common idea that you're going to have to deal with these singularities one way or another. But there were already alternatives out there, and in the time since then, those alternatives or various kinds of alternatives to those singularities have become increasingly popular. So much so that now, today, no one takes them seriously.
Okay, back to the Craig video.
Grayson talks about the Borde-Guth-Vilenkin theorem. Let's go to that clip.
Oftentimes, the Christian apologists will bring up something called the Borde-Guth-Vilenkin theorem, which is exactly what Frank Turek brought up in the video in which I spoke with him. And in that video, you can see that both Guth and Vilenkin, two of the physicists that came up with that theorem, explicitly clarify that their theorem is talking about inflation. Their theorem necessitates that inflation had a beginning. It does not make any such claim about the universe. In fact, Vilenkin very clearly explains that the theorem is agnostic about the beginning of the universe as a whole. In fact, there's no evidence or reason suggesting that the universe itself had a beginning or has to have a beginning. You can have a past infinite universe that is logically possible. There's nothing in the actual evidence, the scientific evidence, that says that that is ruled out. Based on the currently available evidence that we have today, the only honest position is to say we don't know whether or not the universe had a beginning or not, or if a beginning was even required.
More agnosticism, Bill. Is it warranted?
The Borde-Guth-Vilenkin theorem was indeed originally developed to answer the question whether inflation, that is a super rapid expansion of the universe, could be projected not only into the infinite future, but into the infinite past. And what they discovered was that this is in fact impossible if the universe conforms to a single, very general and plausible condition. But the Borde-Guth-Vilenkin theorem applies not only to inflationary models. That seems to be Grayson's misimpression. Any universe which is, on average, in a state of cosmic expansion throughout its history has to connect in a finite time to a past boundary. And far from denying the beginning of the universe, Vilenkin is very blunt about its implications. Let me simply read several quotations from him. Quote, "It is said that an argument is what convinces reasonable men, and a proof is what it takes to convince even an unreasonable man. With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning." That's from Vilenkin's book, Many Worlds in One.
That quote is from a popular paperback book. It's not in the peer-reviewed paper. In fact, I spoke to the person that peer-reviewed the paper, and he said, essentially the quote is in our book, and when you read it, you'll get more. But he basically said, mathematics is good, interpretation is iffy. So, yeah, how is that like a credible? I mean, let's put it this way: Vilenkin thinks, or he did think, that it proved that the universe had a beginning. When I interviewed him, he no longer said that. So that book came out in 2005, and it's a paperback book, right? When I interviewed him in, I think it was 2017 or 2018, I can't remember exactly when. It's just before the pandemic. He said, no, it only proves that inflation had a beginning, doesn't prove the universe had a beginning. I can play the clip if you want. It's up to you, Joe. I've got the clips from Alan Guth and Alex Vilenkin both saying that it only proves that inflation has a beginning. What we should also know is that other people have actually disputed this. So recently, maybe I should play this clip. There was a paper in fact, one of the authors on the paper is Paul Davies. And Paul Davies is someone that William Lane Craig has quoted a lot in the past. And they've put a paper out recently saying actually the Guth and Vilenkin theorem is flawed. It has a sort of mathematical error in it. And I've got a clip from one of my videos. I can play that. Now, I'm not going to say they're right, because this is not how this works, because this is what Craig does. And I don't want to make the same mistake as Craig. Some people will come out and makes a claim, or some cosmologist comes out and makes a claim, and he goes, aha, see, right? We've debunked that model because this guy says it's wrong, you know. And I'm not going to say Guth and Vilenkin theorem has been debunked, but it's pronounced border. Okay. So I'm not going to say it's wrong because these guys published a paper saying it was wrong, right? It's a state of flux, right? This is something cosmologists are debating. Maybe, should I play the clip? Here's Guth, actually. You probably should hear it from the horse's mouth. Why not? So here's Guth and Vilenkin.
I was working with Arvind Borda and Alex Vilenkin to understand what we could
see, pronounced border.
How it might have started and how far back it could have gone. And in particular, once we realized that inflation could be eternal into the future, it seemed like a very natural question to ask. Could inflation have also been eternal into the past?
Also note that it is eternal into the future. It's, you know, infinite number of universes here, which of course Craig thinks is impossible. But anyway.
What we found was that inflation could not be eternal into the past. What we basically managed to achieve was proving a theorem which says that any expanding region of space-time that has some minimum expansion rate can only go back so far and not infinitely far. So that means that inflation must have had a beginning. It doesn't really say that the universe must have had a beginning, but it says that the universe could not have been expanding forever up until the present time.
The theorem proves that inflation must have a beginning, right? The universe as a whole, the theorem doesn't say that. It says that the expansion of the universe must have a beginning.
The theorem says the universe could have not always been expanding. So whether that means there was a beginning, so then beginning out of something else, some other physics maybe, or maybe beginning from a different...
I should just pause it here. This is Ghazal Ghassanjani. She published a paper about the BGV theorem, and PBS Spacetime, the biggest YouTube channel in physics, they just put out a video about this paper. So people should, well, hopefully they'll watch this video because we actually interview her, but they also put a video out, and that's worth watching.
Phase of the universe, which maybe was contracting, maybe it was static. So then we can explore all of these possibilities. I wouldn't a priori rule out any of them.
Theorem, and this is Nihaya Shapshori. He's my co-author. But I think what he has to say is very profound.
Proved by Borda, Guth and Vilenkin suggests that inflation cannot be past eternal, so it must have had a beginning. At least that's the way that they portray it. But what really it is about is there's a trajectory of a particle, if you look at it, it goes back into the past, and what this particle experiences. Now, the question is, does that actually tell us anything about the universe as we know it? Now, particles, as we know, don't actually make up the universe now. So the universe, the quantum universe, is not made out of particles, they're made out of fields. So particles are only an approximation in certain limit. But especially when you go to early times, when things become more quantum, the notion of particle becomes less and less defined. But what does it tell us about our universe? If our universe is not made out of particles, but made out of quantum fields, and it's not necessarily classical geometry, but a quantum geometry. So these are all assumptions that we know are going to break down at early times, and we know fundamentally cannot be correct in a quantum theory of gravity or quantum theory of...
Okay, hang on. Let me just skip to... yeah, this is the new paper. Here we go.
I wrote this paper with my student, Joe Lesnevsky and Paul Davies, where we highlighted that there is an ambiguity in the way that one defines the average expansion rate of the universe in the BGV theorem. And depending on how one defines this, one can get different answers. And because of this, we found that it is, in fact, possible to find solutions which, in general, are inflating eternally into the past and into the future. This is a controversial point somewhat, but mathematicians would say that they used an inappropriate definition for geodesic completeness.
Okay, so, all right, you get the idea, right? Now, again, I don't want to say these guys are right, yeah? maybe someone's going to find a flaw in their paper. But this is what happens in physics: it's back and forth, and the conclusion is still up in the air. That's the point, right? And he can quote, some people, Vilenkin, as saying, Vilenkin thinks the universe had a beginning. He does, right? But I just thought, can I get a dozen cosmologists, like off the top of my head, who think that it might not have a beginning? So I just very quickly, in like a minute, I went, Alan Guth, Roger Penrose, Don Page, Leonard Susskind, Gabriela Veneziano, Abe Ashtekar, Yasunori Nomura, Anthony Aguirre, Sean Carroll, Paul Steinhardt, Robert Brandenberger. There you go. There's a dozen cosmologists that think the universe may not have a beginning. Are they right? I don't know, right? But you can't, what kind of philosophical argument is this? One guy says that the universe has a beginning, so it has a beginning. Is that what, I thought philosophers were really very impressive logical arguments. He's basically just saying one person in a debate has this view and I'm going to quote them. That's just pure cherry picking.
It's also bizarre that he's that he thinks that he can quote someone, and that itself isn't, even if you could quote several people. It's sort of bizarre about the way that Craig is arguing here is that it's the way that someone argues when either they haven't mastered the science for themselves, or they expect that their audience hasn't mastered the science for themselves. Those are the situations in which you appeal to expert testimony, so the experts can speak in your place. It'd be one thing if Craig could himself show that the BGV theorem has the implications that he thinks that it has, for example, but that's not what he's doing here. The other thing to be said is that the BGV theorem is not the only theorem. There's another theorem that I like, called the Millman-Manchak theorem. And the thing about the Millman-Manchak theorem is that what it shows is that in a very large number of different classical spacetimes, there is no amount of data that you could gather that would allow you to infer the structure of spacetime as a whole. What's called the global structure of spacetime. What you need in order to infer not just that our observable past has a beginning, but also that the totality of physical reality has a past, is you need people to make observations that somehow lead you to conclude that the whole of physical reality has the right kind of global structure, that space-time as a whole has the right kind of global structure for the whole thing to have a beginning. Now, it could be that if the BGV theorem doesn't have the kind of mathematical flaw as pointed out in the physical review paper that you were referencing, if it's a bona fide theorem, then it could be that theorem applies to physical reality, or it could be that it fails to apply, even though it applies to our observable universe, in which case we would have no way of knowing that fact, or may have no way of knowing that fact, as per the Millman-Manchak theorem. So it's not just that whether or not it's a legitimate theorem has been called into question, but also that there are reasons internal to the mathematics of classical spacetimes themselves for thinking that even if something like the BG theorem did apply, you could never know that it did.
Okay, two other points I want to make on this. First off, let's just turn Craig's technique against him. If we're going to quote Vilenkin and say he's an authority and what he says goes, let's say fine. Okay, let's do that. So I'm going to quote the same book about what was the cause of the universe. Okay, so here's a quote from Vilenkin, open quote. Before I start the quote, sorry. Vilenkin has this model called tunneling from nothing, where basically the idea is you treat space-time quantum mechanically, and the idea is that space and time fluctuate into existence from a state where there is no space of time. This is not a fluctuation of the vacuum, as Craig mistakenly says. It's a fluctuation of space-time themselves. But anyway, so here's open quote. If there was nothing before the universe popped out, then what could have caused the tunneling? Remarkably, the answer is no cause is required. In classical physics, causality dictates what happens from one moment to the next. But in quantum mechanics, the behavior of physical objects is inherently unpredictable, and some quantum processes have no cause at all. Close quote. So if we're going to take Vilenkin as authoritative on the second premise, why not take him as authoritative on the first premise? The other thing to say is that people will say, we're misquoting Vilenkin because he says, you can violate the BGV theorem by having a past contracting universe, but a past contracting universe is impossible, it's unstable. But that is Vilenkin's opinion, and other cosmologists don't agree. Let me show you a paper that just came out very recently. I'm going to share the screen again. Okay, this is a paper that came out. So this is E.S. and Steinhardt, their famous cyclic cosmology proponents. But David Garfinkel is quite a famous numerical relativist. So they do, very high precision simulations of relativistic models. Very important, like for LIGO and stuff like that. And what they say is that actually, it's a contracting universe that will give you the smooth universe that we get, an inflation universe that doesn't succeed. So it's complete contradiction to what Vilenkin says. Who's right? I don't know, right? But what you can't do is just quote one side of a debate and say, there you go, that proves it. One person said a contracting universe is impossible, therefore it's impossible. No, that's not how this works. This is an active area of research. There's a lot of back and forth, and the answers are not unambiguous here, right? And it's extremely dodgy what he's doing.
Right, and that's where I get the title of the video. I don't think Craig is accurately representing the state of science as we've been trying to show throughout this conversation, and that's why I titled the video as I did. He's just not accurately representing the state of science. So I feel like we got a lot of information there on the BGV theorem. If someone just wants to do like a bullet point summary of the various responses. So Dan, you had like the Malamud-Manchak theorem. You had the other ones where it's like there are various assumptions built into the BGV theorem that we know are at least questionable as they apply to the universe. And then Phil, you brought up some other points about how there have been even recent papers, at least one recent paper, which has called into question some of the mathematics of the BGV theorem paper as originally published. And even the two authors of the paper itself, or at least Borda and Guth, was it? They both, or was it Guth and Vilenkin?
Borda hasn't made much comment. I tried to reach out to Borda, and I didn't get.
So at least Guth and Vilenkin, they explicitly say that the theorem is not about the universe as such, and doesn't show that the universe as such has a beginning.
Well, so here's an objection that doesn't get raised very often, but I think maybe it should be placed on the table for our audience. If you walk in any physics department and just walk up to a random physicist and say, like, well, gee, do we know that the universe had a beginning? And by universe, I mean like the totality of physical reality. Everything that's physical began to exist in the finite past. The answer you're going to get is this: no one knows. Like it's we spend so much time looking at academic views and like talking about all these technical results and so on. It's just anyone who has their ear to the ground in physics knows that the answer, just the bog standard answer, is we don't know enough because we don't have a quantum gravity theory. That's it. That's the standard scientific answer.
Awesome. And I try to provide the bullet list myself of the responses to the BGV theorem point, but I don't know if I missed anything. But
there is other things. If you watch our video on the Kalam cosmological argument, go on my channel, go Kalam argument. We did 2 videos: the initial video and then the reply video. And there are many more things to say, but
okay.
Go and watch the video.
Okay, and then let's get back to the Craig's video.
In 2012, at a conference in Cambridge, celebrating the 70th birthday of Stephen Hawking, Vilenkin delivered a paper which surveyed contemporary cosmology and addressed the question, did the universe have a beginning? And he argued, as I quote, none of these scenarios can actually be past eternal. He concluded, quote, all the evidence we have says that the universe had a beginning, end quote.
Just stop there a second. I'm not going to make the same point that it's one guy's opinion, but just a different point. In that paper, he reviewed 3 models, okay? So one was eternal inflation, the other was emergent universe. The emergent universe is, if you imagine the evolution of the universe as like a line, as it expands, it kind of becomes a straight line, if you go back in time. Then he reviewed the ekpyrotic universe, which is a cyclic cosmology. So he claimed that all 3 are have a finite past. Now, eternal inflation, we've already seen that there are people disputing that conclusion. The ekpyrotic model can fall victim to the BGV theorem because it has increasing expansion. But again, if you go back to Niayesh's point about quantum fields being the more fundamental thing, it could well be that even that model could be past eternal. I interviewed Paul Steinhardt about this for the book, And he said, well, they're making assumptions about the mass of particles being constant. I don't agree with those assumptions. So again, you've got this debate, and even in the emergent model, that one hasn't been so well received. I know Sean Carroll doesn't like it. I know Anthony Aguirre published a paper saying, no, it can't be, it doesn't really work. But there are other people like George Ellis who see that it can work, And again, it's a back and forth here. So be aware that paper reviewed 3 models of the early universe. In our book, I think we have more than 20. Right? But even if he was right about all those 3.
Right. And this is exactly the point that I raised earlier, right? That just no model is probable. It can't be, mathematically speaking. If you think that all these models are worth taking seriously, then it's just not true. That there's a model that is there's more than 50% probable, mathematically speaking. That can't be so. Which means that that every model is individually improbable. That does not mean that the features that appear in those models are individually improbable. This is part of the way in which it works in physics to propose a model, is that you don't propose a model that you think is going to be probable in every detail. What you do is you propose toy models that may capture some features that a more realistic final theory could have, and then you explore how that works within the context of that toy model. And what Craig and others have done is they just haven't taken seriously the way in which cosmologists themselves evaluate models or the motivations they had for proposing them in the first place.
Yeah, and I just want to give a kind of analogy. So it's like there are some aspects of science that are definitely settled. Things like, as we said earlier, that at least our local space-time manifold, the observable universe that we inhabit, started to expand about 13.8 billion years ago from a very hot, dense state. It kind of began to rapidly expand from that state. Now, that's something that is uncontroversial. But when it comes to these more controverted and controversial things in physics, quoting whoever he quoted here, was it Vilenkin? Quoting a particular quoting Vilenkin here and his particular assessment of 3 other models, and his various arguments and objections to those models and whatnot, which have been extensively discussed by other people, and they disagree with his conclusions. It's just it's as if we're quoting a philosopher in an active area of philosophical disagreement and just saying as Josh Rasmussen has said, God exists, and so we can continue. But it's listen, sure, Josh does give arguments for that conclusion that God exists, and Vilenkin does give arguments for his conclusion and whatnot. But it's the current state of the academic philosophical literature is such that there's very big controversy as to whether or not Josh Rasmussen's arguments succeed. And it's not as though it's a settled philosophical fact that God exists. And similarly, you can quote a particular physicist's assessment of some other models, again, 3 out of the around 24 that Phil mentioned. You can quote his particular assessment of that, but we can't be treating that as if it's some scientific fact and then using that within our case to assert that the universe began to exist, again, as if it's a scientific fact. Again, this is just one physicist's it's his view, but it's his considered view. But again, this is an active area of research and contention and controversy among the relevant experts. And so it is just overwhelmingly premature.
Just a bit of fun here. Vilenkin is a very well-respected cosmologist, but we might ask why. What was his major contributions? And 2 of the main things that he's famous for, Craig is extremely antagonistic to. So one is his quantum cosmology model, the tunneling from nothing, right, which Craig is absolutely antagonistic to. And the other one, of course, is the multiverse and eternal inflation, that there's an infinite number of other universes. Again, Craig antagonistic to. So it is odd that, and of course, Vilenkin, as we said, thinks that there was no cause for the universe. So again, so many things he would be really opposing Vilenkin on. But the one thing that he agrees on, quote him till the cows come home.
So the other thing that we brought up here is that we've talked about how this is an active area of science and people are proposing all these different models and there's controversy among them. We treat them as toy models, so we don't think that they should be realistically regarded in everything that they say. But there's another thing to be said here, which is that even in well-established science, even in areas of science where we have a very good idea of what's going on, people use models that themselves are not always realistic. So, for example, in models of infectious disease, you might, if you're writing a computer model of an infectious disease, for instance, you might create a model where you model people as like little particles that move around, and then they can transfer their state to another particle, right? So that's like analogous to them transferring a disease to another person. But of course, you can say, oh well, human beings are not particles moving in a plane. They're not point-like. They don't move randomly. And so you could say, oh, well, there's all sorts of ways in which this model is improbable. Well, yeah, but that's not relevant, right? What's relevant is whether or not, like, how should we understand what scientists take to be the central lessons that come out of the model about, for instance, the rate at which a disease spreads through a population. Likewise, when we evaluate cosmological models, what we shouldn't be doing is saying, oh, these models are all each individually improbable, so we're going to declare that there's just no way that the universe could be past eternal. Rather, what we should say is, what sort of general lessons can we draw from these models about what a past eternal universe may be like, at least according to physics as we currently understand it, or physics that's maybe just over the horizon of what we understand. It's a very different way of framing the issue than what Craig and other Christian philosophers or apologists, how they usually frame the issue.
Okay, let's get back to the video.
That the universe had a beginning, end quote. In an article in the online journal Inference, published in the fall of 2015, Vilenkin strengthened that conclusion. Here's what he says in that article, quote, we have no viable models of an eternal universe. The Guth-Vilenkin theorem gives reason to believe that such models simply cannot be constructed, end quote. So he argues that not only...
So of course, we've already addressed the points here.
Not only do we have no physically viable models of a past eternal universe, but that his theorem gives reason to believe that such models simply cannot be constructed. Now, what about his colleague Alan Guth? In my debate with the cosmologist Sean Carroll, Carroll tried to quote Guth to the effect that the universe probably didn't begin to exist. And Carroll was bewildered. He said, how could the author of the Guth-Vilenkin theorem deny that the universe had a beginning? Well, the answer to that question was revealed by correspondence between Alan Guth and the philosopher Daniel Kalam in England, in which Guth revealed that what he was talking about in that quotation was Sean Carroll's own model of the universe, the so-called Carroll-Chen model. This is a model which features a reversal of time at some point in the past. The arrow of time, instead of running forwards, flips over and runs in a backwards direction. Now, this Carroll-Chen model is not only outrageously non-physical, featuring such a reversal of the arrow of time, but even more fundamentally, it actually implies the beginning of the universe, because those two arrows of time, those two expanding universes, have a common origin point, which represents the beginning of both. Far from representing a past eternal universe, what you have is two expanding universes in different directions in time with a common point of origin. And so it turns out that the model actually implies rather than denies the beginning of the universe.
Yeah, a couple of things to say about this. So firstly, he's like, Carroll was bewildered. No, it was a rhetorical device. Carroll wasn't bewildered. And it wasn't actually, he says it was revealed by Daniel Kalam. We did an interview, put it out on video on YouTube. He's got hundreds of thousands of views with Guth explaining this, right? Why does he not mention that? He'd also written an article in Edge magazine, I think even before that, saying that he thinks the universe is past eternal. Now, this question of and then he also says, it's completely unphysical. I mean, what's the justification for that? Where's your documentation, Craig? You can't just assert that without justification. A lot of different models have this flipping of the arrow of time. It's a whole class of different models. So for him to just say it's not physically meaningful, whatever it was he said, I think is extremely dubious. Now, the question of the interpretation, is this a model of the beginning or isn't? I mean, notice he just says it explicitly. This model has a beginning, right? Rather than I think it has a beginning, I would interpret this as having a beginning. That would be a bit more honest. And he knows other people disagree with him, right? He knows that because after the debate with Carroll, well, he knows that Carroll disagrees with him because in the debate, Carroll said, this is the middle. This point is the middle. There's no way you could think of this as the beginning. Certainly no creation ex nihilo, right? Because the universe does not come into existence at any point in that model. So, and Craig thinks God created the universe ex nihilo, so he wants to match these things up. I don't think he can do that. But anyway, after the debate, John Page, who is a very well-respected cosmologist, there's even an effect in physics called the Page time named after him. He was a student of Hawking. He's also an evangelical Christian. And he wrote a letter, an open letter, to Bill Craig, which was published on Sean Carroll's blog. And I think I should read a little bit of it. So let me just pull it up here. Open quote. Bill, on this issue, we simply do not know whether or not our universe had a beginning. But there are certainly models, such as Sean's with Jennifer Chen, that do not have a beginning. I myself have favored a bounce model in which there is something like a quantum superposition of semi-classical spacetimes. Though I don't really think quantum theory gives probabilities for histories, just for sentient experiences, in most of which the universe is contracts from past infinite time and then has a bounce to expand forever. In as much as these spacetimes are approximately classical throughout, there is a time in each that goes from minus infinity to plus infinity. In this model, as in Sean's, the coarse-grained entropy has a minimum at or near the time when the spatial volume is minimized at the bounce. So the entropy increases in both directions away from the bounce. At times well away from the bounce, there is a strong arrow of time. So that in those regions, if one defines the direction of time as the direction which entropy increases, it is rather as if there are two expanding universes, both coming out from the bounce. But it is erroneous to say that the bounce is a true beginning of time, since the structure of space-time there, at least if there is an approximately classical space-time there, has time-like curves going from a proper time of minus infinity through the bounce, say a proper time 0, and then to proper time of plus infinity. That is, there are world lines that go through the bounce and have no beginning there. So it seems rather artificial to say the universe began at the bounce that is in the middle, close quote. And also I'm going to play a little clip. Now, that's someone who's very much in agreement with Sean Carroll, okay?
There are places you can find where Craig offers an argument of some kind here. So what Craig points out is that it's often thought that the direction of time is defined in terms of the direction of the entropy gradient. The direction in which the entropy is increasing is usually taken to be the future. So if you have two different directions in which the entropy is increasing, then you have two different future directions, or so says Craig. But of course, on the one hand, Craig himself endorses a metaphysics of time on which that's not how the future direction gets picked out. And on the other hand, balanced cosmologies themselves don't require that the entropy be minimum at the bounce. It happens to be a feature of some models, like the Carroll-Chen model. But you can write down models, very easily write down models in which that's not true. Anyway, I'll let.
But in the book, actually, we distinguish between a bounce model and a Janus model. So the way I would think, they both look the same. If you looked at them like from a God's eye view, they look like an hourglass, right? But if you were in the other branch, so we're in our branch expanding out here, right? If you were in the other branch in a Janus universe, you would see your branches expanding. But in a bounce model, the way up, what we call it, you would see it contracting, right? So there are some models of these hourglass universe where time goes like this, and there are some where it just goes like this.
Right, and that's defining the direction of time in terms of the entropy gradient. Yeah, but again, if you have a metaphysics like Craig's, in which that's not how the direction of time gets picked out, then there's that wouldn't be, those two arrows wouldn't be the future directions. You might mistakenly think that one of the things that's like strange, if you're in if Craig's metaphysics is right and you're in a Janus universe, then you actually have this kind of skeptical disaster that happens to you where you don't know whether the direction that you think is the future is actually the future, because there's going to be a whole lot of observers potentially in the other on the other face, as it were, who think that particular direction is the future, but are wrong about it.
And I just want to mention also the metaphysics that you just mentioned is actually very important for Craig in responding to various objections to the Kalam and whatnot. So like his Kalam arguably rests on this kind of metaphysics, which conflicts with this view about time and the entropic direction, et cetera. So. But yeah, go on, Phil. I know you might want to share the screen as well.
Yeah. So what? Yeah, I will share the screen in a second. He said it was all based on Carroll Chen. Not really. It's based off a more general idea that actually I think goes back to Anthony Aguirre and Steve Grattan. What Guth and Carroll were talking about doing was writing a paper which would, I think, make it broader. Now, one thing to make a note on, Christianity did a video with like Aaron Wall and a couple of Christians, and one of them, I can't remember who it was, said, "Oh, this paper is a lie. It's never coming out. You know, Carroll was lying." But this guy doesn't know Alan Guth, because anyone that knows Alan Guth knows that he's kind of slow at doing papers and things. And in fact, Alex Vilenkin, he's very careful. I mean, in a way, it's a great thing because he's extremely precise and careful whenever he does stuff. But Alex Vilenkin, I think, in his book said he was the world's biggest procrastinator. So the way that cosmology and, well, probably any science works, maybe philosophy as well. You know, people talk about writing papers together, they start on it, and then they put it to the shelf, and then they don't revisit it. Or maybe 20 years later they do. In fact, I interviewed the book, and I asked about it, and he goes, yeah, I still want to finish it. You know, if you see Sean, tell him, you know, I've actually got some time now, but Sean, I guess, was busy, you know. But so it wasn't specifically the Carroll Chen model. It's a broader idea. But now, to be fair to Craig, there are some people that, well, I've not heard people say that this model does have a beginning, but maybe it's ambiguous. But actually, before I play that clip, the interesting thing is that what Guth and Carroll are trying to do is solve the mystery of the low entropy at the Big Bang. So they're trying to do that. And what's interesting is that's Penrose's motivation as well. And even though they've got completely different schemes, they both think that the universe is past eternal. And I actually asked Guth about this, and the answer is quite interesting. So let me play the clip here. One sec.
There's this puzzle of why is the entropy so low at the Big Bang? And Roger Penrose has been talking a lot about this.
Yes.
And his solution is that the universe is eternal, and there's something that puts the entropy into a low state. Now, he obviously has a very different mechanism. But would it be correct to say that you're kind of agreeing with him in that the eternal universe is a solution to the second law problem?
Well, I think we're agreeing with that phrase, right, but no further than that phrase. Right. His notion of eternal is very different from this one, because this one really divides the universe into two halves, where, and it's never cyclic. The universe gets bigger and bigger this way and bigger that way. Right. His model is cyclic, cycle after cycle after cycle.
This was recently dubbed, I think, the Janus universe, which is kind of a nice name for it, I think.
Actually, this is Anthony Aguirre, by the way.
There's two faces to the universe. Mm-hmm. So in that version of the universe, the theorem is upheld in the sense that the definition of the expanding universe that you had up here doesn't hold down here. So according to that definition, the universe down here is contracting. Is that a universe that is past eternal? You can question that in the sense that you could say that this is t equals 0 and time increases this way and time increases this way. So it still has a beginning at t equals 0. On the other hand, you could say, if here we are at t equals 13.8 billion, say, there are an infinity of times to our past. That's also true. So I think there's a legitimate debate as to whether that model of the universe is past eternal or not. But there are other possibilities too, as to how the universe could be in accord with the Guth-Vilenkin theorem, but could, I think, really be past eternal.
I wrote this paper.
Okay. Okay. So to be generous, so you can imagine Craig's probably going to quote the bit where he says that model has a beginning, and ignore the bit where he goes, but it's also eternal into the past. Anyway, but the point is, there's a debate on how to interpret that, right? And what Craig does is just quote one side of the debate and then say it's settled, but that's not what's going on in the real world. Now, notice that Anthony Aguirre said there are other models, and I think can be past eternal, right, unambiguously past eternal. Now, the irony here is that in the debate that Craig had with Carroll, he quoted Anthony Aguirre to back up his view that the universe cannot be past eternal. How dodgy is that, to quote someone who thinks the universe can be past eternal to make your case that it can't be? That is extremely dodgy. But anyway.
Okay, continuing on with Craig.
One more clip from Grayson. Here he presents the new fixed Kalam cosmological argument. Let's go to that.
So now if we fix premise 2 based on the actual available evidence and most up-to-date science, premise 2 now reads, the universe may have begun to exist, although we cannot know for sure. So now let's put it all together. What is the new fixed updated and accurate version of the Kalam cosmological argument tell us for its conclusion? Let's summarize. Premise number 1. All things that begin to exist are created from other previously existing things. Premise 2. The universe may have begun to exist, although we can't know for sure. The conclusion that logically follows from these premises is the universe may have been created from other previously existing things, although we cannot know for sure. Isn't it strange how when you update the premises of the Kalam cosmological argument to more accurately reflect the most current up-to-date understandings of science and philosophy, all of a sudden the conclusion is quite sensible indeed. I don't think anybody would take any issues with such a conclusion in the fields of science or philosophy. It's no small wonder that the Christians don't want to go anywhere near it, because all of a sudden it's going to be pretty tough to figure out a way to smuggle your God into that conclusion.
Well, what about his fixed version, Bill? And by the way, I noticed that he calls any further analysis smuggling this time.
Yeah. I was really surprised by this reformulation because he hasn't said anything to justify his reformulated premise 1. His reformulated premise says everything that begins to exist has a material cause. And he hasn't given any reason to think that that's true. There's no conceptual reason to think that something cannot have an efficient cause, but no material cause.
So, I mean, I want to comment on that briefly. Did he really provide no reason whatsoever? I mean, it seems like he was giving an inductive argument for it. He's saying, like, listen, every time we look around us and we see material objects begin to exist, it seems like they always come from pre-existing things. At least my sense was that he was there kind of appealing to our universal experience, which is something that Craig himself does, right?
That's right. He gave 2 arguments. One was from this universal experience of things coming into existence with material causes. None of the things that we were experiencing coming into existence come into existence ex nihilo. And then the other argument that he gave was a kind of semantic argument. He argued that what it means to say that something begins to exist is that it comes from pre-existing stuff. Now, of course, that latter argument is more philosophically controversial than the former.
Yeah, I don't like that one.
Right, but you know, it's just strictly speaking false that he offered no arguments. He offered 2.
Right, and earlier on we were gesturing towards a kind of intuitive argument for this. I gave the case of the log cabin to kind of probe our intuitions. It's the exact same thing that Craig does when he's talking about, well, he wouldn't take seriously that like a Beethoven or bicycles or root beer could pop into existence uncaused.
And in fact, I think we can even give some examples of things that have efficient causes that don't have material causes. For example, abstract objects like works of art or musical compositions or the equator are objects that plausibly have causes. They're composers and artists that produce them, or the planet Earth that comes to form causes an equator to exist by its spherical shape. But there are no material causes of these entities. So even if they have efficient causes, there is no material cause. So he simply hasn't justified his first reformulated premise. There's no reason to think that in the case of the universe, that the universe does have a material cause. In fact, the evidence is quite the contrary. That's all matter and energy, space and time themselves came into being at the moment of the Big Bang. And therefore...
Okay, so before I turn it over to you guys, I just wanted to comment on this. So firstly, I thought that this was a bizarre kind of counterexample for Craig to give, because Craig, as far as I understand, is like a staunch nominalist. He doesn't believe that there are such things as abstract objects. So I don't see how we can pose this as some kind of counterexample, that at least some abstract objects begin to exist, are efficiently caused to begin to exist, but don't have material causes. So that was very, very odd. Like he doesn't even believe in abstract objects. If he did believe in abstract objects, that would pose a huge challenge to his entire life's work, because first of all, abstract objects pose a pretty serious challenge to theism. He has a book called God Over All, where he out details the problem that they pose for theism. It challenges God's aseity, its sovereignty, but also they pose a challenge for the Kalam cosmological argument, because if there are abstract objects, then very plausibly there are going to be infinitely many of them. Think of like the number 1, the number 2, the number 3, the number 4, and so on, or infinitely many different shapes, or infinitely many different etc. Properties. And of course, that contradicts Craig's claim that actual infinities, collections of items which can be paired in one-to-one correspondence with the natural numbers, that poses a challenge to his view that those are impossible. So he doesn't even believe in abstract objects. So by his own lights, this isn't a counterexample. Secondly, this would pose a challenge for his own theism. By his own lights, he has extensively defended this as a challenge. Abstract object is a challenge to theism. And thirdly, it would pose a challenge to his defense of the Kalam cosmological argument. So, and then I guess the fourth and final point that I want to make is that it is actually, even among believers in abstract objects, it's extremely controversial that we can somehow kind of create them and bring them into being. A lot of philosophers are going to say, no, actually, these abstract objects like spheres and musical compositions and whatnot, they actually exist as abstract types and have always existed as abstract types. What we do is we instead causally bring about various token concrete instances of them. Right. But the token concrete instances do have material causes, like the particular concrete token instance of a symphony that someone comes up with. That does indeed have a material cause. So even among proponents of abstract objects, a number of them do not like the view that we somehow bring into existence abstract objects. Instead, they always exist, and we only ever bring into existence concrete tokens and instantiations. So I'll turn it over to you guys.
I think you're right that these are bad examples. We're looking for examples of things that begin with an efficient cause but not a material cause. But I think the situation is even worse for Craig, because there are really actually famous examples in philosophy of things that have been claimed to have material cause but not an efficient cause. So the most famous example that I can think of is an example originally discussed by David Lewis. Lewis makes the claim that white dwarf stars that they do not have a cause. That there is no entity that brings the white dwarf star into existence as its efficient cause. Instead, others have argued that what explains the existence of the white dwarf star are a set of kinematic constraints on its parts. Of course, there is pre-existing matter that goes into the formation of the white dwarf star. So while Lewis didn't discuss material causation when he discusses the white dwarf star example, it's easy enough to see that if Lewis is right about the white dwarf star, then what we should say is that the white dwarf star has a material cause but not an efficient cause. That example is not one that I can remember seeing Craig discuss anywhere. He certainly hasn't discussed it in any of his popular presentations. And there seems to be a complete dearth of discussion of that example in the literature on the Kalam cosmological argument. Nonetheless, in the causation literature, it's a really famous example of something that begins to exist or is formed without an efficient cause.
Yeah, and so lest, of course, and I know you mentioned how people have argued this, lest we give an impression to the audience that this is settled. It is philosophically controversial, in the philosophical literature, whether this case succeeds. We want to be very upfront about that. But right. It's something that the Kalam proponents at least need to be aware of, and if they want their case to succeed, they need to address it. For those who are interested, I could just point readers to a recent paper in the Routledge Handbook of Philosophy of Physics. It's called Non-Causal Explanations in Physics by, I think it's Juha Satsi. I don't really know how to pronounce it, but I'll put that up. Yeah, I'll put that up on the screen, and I'll also put it in the description.
That's a great example. And Satsi mentions in that paper that there's some other examples that are similar to Lewis's as well, like the formation of a covalently bonded molecule. Satsi argues that covalently bonded molecules don't have efficient causes for their formation, but that they do have an explanation for their formation. That the explanation for their formation is in terms of a set of kinematic constraints on their parts.
Awesome, and yeah, again for the audience, these are controversial, but they are argued extensively in the philosophical literature. So,
I have a question for you guys, because you're the philosophers here. Doesn't he believe in simultaneous causation? Right. So now, in our Kalam video, we interviewed a bunch of physicists and philosophers, and they said there's no such thing as simultaneous causation. But suppose there is, right? He said that the universe couldn't have a material cause, but he also thinks that the Janus universe is two universes stuck together. So could it not be the case that they were simultaneously causing each other? Is that impossible?
So in my in some of my papers, or at least one of my papers, I've argued that if you had a bounce model like that, one way to construe it is that both universes are the cause of each other, the simultaneous cause of each other. I think one thing that's important to point out there is that in that context, I was talking about efficient causes. I don't know what it would mean for. I'm not sure if you could have like two objects such that one or both of them are the simultaneous material cause. I guess what you could have is like.
So I think the example he gave, that Craig gives as simultaneous causation, is the ball on the pillow, right? So
so that's right. So that's an example of a simultaneous cause. But the question is whether or not you can have, like, what bearing does that have on material causation? Certainly, if Craig is right that the ball is a simultaneous cause of the indentation in the pillow, I would object to that example. But in any case, if we take that example seriously, then what we would say is that the ball is the efficient cause of the indentation in the pillow. In order for one thing to be the simultaneous material cause, presumably the material that's composing an object in some sense is the simultaneous material cause of that object. But maybe what we want is like where we have two non-identical objects where one of them is the simultaneous material cause of the other. Sometimes people will argue like this. They'll say, well, if you have a statue, the statue is not identical to the clay out of which the statue is composed. But maybe the clay and the statue are existing there together at the same time. And then we could, in some sense, say that the clay is the simultaneous material cause of the statue. I'm not sure if that example is problematic. I think that example is right. Joe, do you have any thoughts about that?
Well, I don't want to get too much into the weeds about causation because we're getting close to the end and we should probably continue. I mean, just very briefly for the audience, Dan and I, in our book, Existential Inertia and Classical Theistic Proofs, in chapter 6, we have a very large section on causal simultaneity and, purported examples of simultaneous causation. And what we say therein is going to be extremely relevant to this purported example of a ball on a pillow. We address examples that are just relevant, exactly relevantly similar to that. And what we say therein applies mutatis mutandis to this case. So that's one thing to mention at this juncture. The second thing to mention at this juncture is this is another case where, philosophers disagree with one another. So I am skeptical of kind of mutual efficient causation. So just want to flag that for the audience. This is one case that I'd be very skeptical of. But I guess before turning back to Craig, I know some people are probably thinking, well, you guys haven't addressed the second law of thermodynamics. So maybe I'll turn it over to Dan to briefly say something about whether or not the second law of thermodynamics proves that the universe began to exist. I guess the idea would just be that if the universe were past eternal, then we would have run out of usable energy by this point, per the second law of thermodynamics. But of course we haven't, and so the universe can't be past eternal. So what do you make of that kind of argument, Dan?
So there's a bunch of things to be said here. I mean, again, this is an area where there's tons of controversy. Like, what exactly is it that explains the large-scale thermodynamic gradient that we see in our universe? The fact that everywhere we look, we see the entropy going up. One possibility is that even though the entropy is going up here and now, maybe that's not what the entropy has always been doing or is doing everywhere. So you can have these kinds of models where the entropy is somehow dynamically reset. And in a model like that, you'd have some low entropy condition in the past. Now, there's various kinds of objections that I won't go into that presented to those kinds of models. There are other models where the entropy is just always increasing and always has been increasing. The fact that you have some quantity that's increasing over time doesn't tell you that there's some point at which that quantity began to increase. You can write down mathematical functions that cover the entire real line, but nonetheless never dip below zero and are always increasing. They can be functions that are monotonically increasing, but that asymptotically approach zero in the negative direction. That's the kind of technical terminology you'd have for that. There may also be, this is a more speculative possibility, but this is less popular, but it could be that there's something just fundamentally wrong in our understanding of the universe's entropy. So somehow we've tricked ourselves into thinking that the physics that we have requires this large scale thermodynamic gradient. Maybe we're just been completely wrong about that. Maybe even though we're right about that here in this epoch of the universe's history, there's some other epoch during which what's going on involves some kind of physics that we don't understand. But in any case, as we've said for all these other cosmological issues, there are tons of different proposals on the table that may help to explain why we observe the kind of large-scale thermodynamic gradient that we observe, and there's no, at the moment, easy resolution to that debate.
In our video series, if you go on my YouTube channel, Phil Halper, go on playlist, go before the Big Bang. We've got all these different models and lots of different solutions to this entropy issue. And in the book, Battle of the Big Bang, we're going to cover this issue. So what bottom line is, there's no agreement, lots of different types of ways of thinking about it, and it's all up in the air at the moment.
Awesome. And of course, there's the ever-present threat of, or the ever-present objection that even if these sorts of considerations show that the past must be finite, which again, we've just given reasons for thinking that they don't show that. But even if they did, that would not suffice to show that the universe began to exist. Just return to the earlier point about the finitude of the past not being sufficient for beginning to exist. Okay, so onwards we march to Craig's video.
Space and time themselves came into being at the moment of the Big Bang. And therefore, the universe, while plausibly having an efficient cause, does not and cannot have a material cause.
Well, Bill,
very briefly, I just wanted to add, Craig is basically saying, well, we have ample evidence that space and time and all of matter and energy and whatnot did actually come into being, and so could not have had a material cause. And that's allegedly a challenge to the principle that, whatever begins to exist has material cause. There are two things to be said at this juncture. First, we can alter the principle. Again, remember I said that there are more restricted versions of the principle, and the principle can be more carefully stated as every material thing which begins to exist, if it has an efficient cause at all, it also has a material cause. And that is totally compatible with the universe beginning to exist and yet lacking a material cause, because that's compatible with the universe just lacking an efficient cause as well. And so you could still maintain the principle and all the motivations for the principle and accept what Craig just said. That's the first thing to say. The second thing to say is that his objection to this, or his response here to this objection to the first premise, is now relying on his arguments for the second premise. And so his sort of justification for the first premise is now kind of parasitic on his justification for the second premise. And we've already seen why that justification for the second premise is seriously wanting. So that's the second point to make at this juncture. And then the third point to make at this juncture is that the very fact that we have such good evidence to accept this material causal principle, together with Craig's claim that that principle is incompatible with all of space-time, matter, and energy beginning to exist, that can just defeat Craig's own claim that space-time, matter, and energy began to exist. We've just discovered by Craig's lights for the incompatibility claim that the material causal principle is incompatible with space-time, matter, and energy beginning to exist, together with the independent reasons that we do in fact have to accept the material causal principle. Those themselves give us reason to doubt Craig's claim that the universe and all of space and time and matter and energy began to exist. So we can just run the argument in the opposite direction, as Craig does. And it's not clear why we should prefer one direction as opposed to the other. We'd ultimately just have to compare the weights of the reasons that we have for accepting the material causal principle with the weights of the reasons that we have for accepting that all of space, time, matter, and energy began to exist. And again, this is assuming that we don't carefully formulate the material causal principle in the way that I suggested. And it's also assuming that Craig is right, that there's an incompatibility between them. And of course, I've already independently challenged those sorts of things. So I just wanted to say that about Craig's response there. I noticed that we didn't actually respond to him, and that's at least my response.
Run one more clip past you today. It's short and sweet. This is a short from the Deep Drinks podcast called The Ultimate Debunking of William Lane Craig's Apologetic Tactic. Here it is.
If you're going to make the argument that it had to come from something, then so does God. Well, not God. He's outside of that. Why? And there is no why, except that you want him to be the first cause, because that answers your weird, creepy little apologetic tactic. And it simply doesn't work. I think they get the most attention because you can dress them up like William Lane Craig's Kalam it's simple with its premises, but when you actually hear him explain it, he's using so many philosophical terms and really impressive language that you feel like, how do I fight this? How can I break this down? But all he is saying is, my God is the one exception. And it's like, that's not an answer. That doesn't answer anything.
And by the way, Bill, that's another thing that I run into quite often. That is the questioning of your motives. And that's what he's doing here, claiming you're just trying to snow people with big sounding words. That and special pleading?
Well, he seems to think that it's special pleading, but I don't think that he understands the first premise of the argument. The first premise of the argument is that whatever begins to exist has a cause. And the reason that God doesn't need to have a cause is because God didn't begin to exist. So it's not special pleading for God. Any being that never began to exist, that is eternal, it's difficult to see how it could have a cause. It certainly couldn't have a prior cause in time. So God is not an exception to the first premise. We're not saying here's something that began to exist, but it doesn't have a cause. That would be special pleading. That would be making the entity an exception to the first premise. But in this case, that's not what's happening. Rather, God doesn't meet the condition laid down in the first premise for needing a cause, and that condition is that the thing began to exist.
Well, Bill, as we wrap it up, I know you'd probably like to scold these guys for not doing their due diligence. You know, I say that because there's a lot of smirking and snickering and things like that in these videos, but maybe we can offer them some advice. I know the temptation is for them to crank out content to grow their channels, but perhaps they should devote a month or two to examining yours and others' responses to their rebuttals before they crank out a video on the topic.
Yes, I think that would be a good idea because these are not new objections. These are objections that have been multiply addressed before. But I think there's a lesson too for our listeners, Kevin, that I'd like to highlight here. And that is, do you notice that these fellows, particularly Grayson, didn't give any documentation for their opinions? They just asserted them. And if there's anything that the internet generation has learned, it is to be skeptical about things you hear or see on the internet. Anybody can get on and make assertions. And so whenever you hear people making assertions, you always need to think critically and ask, what is the documentation that he gives for that? In my responses today, I was careful to give documentation to Vilenkin's and Hawking and Penrose's statements that our viewers can check out for themselves. And so I would encourage people, when you listen to these popularizers, don't be gullible. Don't think that they're authorities on this matter. Ask for the documentation that supports their assertions before you buy into them too quickly.
The irony. Oh, the irony. Like, touche. You know, he had that quote from Misner, undocumented. He said it was a quote from Hawking and Penrose. It wasn't. It was a quote from Hawking. And it was, he asserted that Carroll's model was unphysical. He didn't provide any argument for it. I mean, on and on. He quotes Vilenkin, but he doesn't quote other people that disagree with Vilenkin. You know, on and on we can go. I mean,
but even if you had, suppose that all the YouTubers that they watched clips from did give very careful citations. Suppose that were true. Why would that matter? I mean, you can find sources for all the different things that those YouTubers said, but that's not the way that you settle arguments in philosophy or in physics, right? The way that so the only place I can think of where you could settle a dispute with a citation is in when you're doing history. If the question is, what did some particular historical figure think at some particular time? Well, if you can find some citation, some source where they actually tell us what they think, then that would be, that would settle the issue. But in order to settle this issue, it's not enough just to say, oh, in some popular book somewhere, this guy said such and such. I think it's very telling that they talk about who is an authority. There's this kind of religious way of thinking about or conceiving of these issues where what you have to do is you have to appeal to some relevant authority. Well, that's not the way that real academic work is done. You don't go around appealing to authorities to see what we should actually think about some subject. Instead, you go out and you do the careful academic work of digesting the material for yourself. And then after digesting the material for yourself, you figure out how to understand that material, what implications in this case that material has for whether the universe had a beginning. That's what Craig should be doing, and it's, to be fair, what various YouTubers should be doing as well. But instead, Craig wants to know who the right authorities are to go to, as if we were like debating scripture or something, right? Like,
right. At least in this video. I mean, as you know, of our audience should know this, but Dan is extensively engaged with Craig and Sinclair's work, where Craig and Sinclair, try to engage with the science and the scientific literature and whatnot. So,
but even in those places, though, the Craig and Sinclair paper is very strange because there's two of those papers, but they're both very strange because a lot of what they do is they reprint emails that they have received from various physicists. You get the impression that, okay, they tried to understand the science to some level. They got to some point where they felt like they were stuck. And then they just emailed people, lots and lots of people. And those people were patient enough and careful enough to send them back emails. And then instead of bringing those emails into their own understanding and making the material their own, they just included entire paragraphs quoted from those emails. And so again, it's just this game of like, who has the best authorities? And it's like, maybe if you're doing a certain kind of like scriptural exegesis or something, that's an important thing to do. But, outside of exegesis, outside of historical work, I don't think there's really a place for saying, like, which authorities should we turn to?
And I would say that in science, the way we decide a controversial issue, if the experts don't all agree, which they don't, is via experiments, right? And as far as I know, there's no data that tells us anything about what happened before the inflationary epoch. If the inflationary epoch even happened, there's dispute. I mean, most cosmologists think inflation happened, but not everyone does. So there's dispute about whether inflation happened, and certainly there's no data to tell us what happened before inflation at the moment. There might be in the future. Even then, I wonder whether you could really decide this issue with any kind of data. I don't know of any potential signal that would say, yes, that will show us the universe definitely has a beginning. Maybe someone will come up with something, but I don't think we have anything yet. But I'm very sure we don't have anything yet.
Yeah, and I think that's the sort of one of the central takeaways from our discussion is that, quoting these select few physicists in these ways is not accurately representing the current state of science and the current state of cosmology. I think that is just the broader takeaway. And we've also looked at various different arguments here, the second law of thermodynamics. We've gone into the BGV theorem. We've talked about a lot of stuff. The objections from the illicit slide from finitude of the past to begins to exist. We have we've covered a lot of ground here. So I don't know if you guys have any other final comments, but I'll turn it over to you guys before I do my little outro. Unless you don't have any final comments, then I can just end it.
I think people should watch the other videos in your Kalam series, Joe, because many of the arguments we talked about here today, including a bunch of the objections you just discussed, are discussed in length in other videos in that same series.
I'm going to shamelessly plug my book. Don't forget, buy that book, Battle of the Big Bang. It goes into all these issues. And on my YouTube channel, we've got the cosmology, just go on cosmology playlist. And hopefully we will have an actual debate between two very respected cosmologists. And it will be, did the universe...
And the last thing is that we should plug the podcast that both Phil and I and Alex Malpass appear on, called The Sci-Fi Show. It's hosted on Phil's channel. It's also available on Apple Podcasts and a few other places. There's an RSS feed that you can use to populate wherever you like to get your podcast.
Yeah. And the best guest you've had on there is yours truly. Not So thank you guys again for coming on. I have put links to lots of different papers and work and citations and whatnot in the description. You can check out Dr. Linford's dissertation down there, freely available. You can read it right now on your smartphone while you're on the bus. You can read it to your children for a lullaby. That'll be fun. You can also check out the description for Dan's website, for Phil's YouTube channel, various other sorts of things, playlists. All that is down there. So if you're interested in the Kalam, if you're interested in science, if you're interested in cosmology, check that stuff down there. And of course, if you made it this far in the video, you probably see value in the work that I do. So please consider becoming a patron or making a one-time donation. Links to both of those are in the description. Any amount helps me through grad school. It is much, much, much appreciated. Much love to all you guys. You get some cool and exclusive goodies as well. So, of course, what better way to end is there than I'm Joe Schmid. This is The Majesty of Reason, and peace out.